Imagine a world without maps. A world where the unknown remains just that, unknown. We wouldn't know where we are, where we're going, or how to get there. The wonders that lie beyond the horizon would remain a mystery, forever out of reach. Maps are our guideposts, our windows into the unknown, and our tools for exploration. Today, a new kind of map is being drawn, one with unprecedented detail and accuracy, capturing the world in ways we've never seen before. It's a map built with light, a map that reveals the true shape of our world, a LiDAR map. LiDAR, which stands for Light Detection and Ranging, is revolutionizing the way we see and understand our planet, offering insights that were once unimaginable. It allows us to peer through dense forests, map the ocean floor, and even uncover ancient ruins hidden for centuries, bringing history back to life. It's a technology that's changing the world, one laser pulse at a time, transforming our understanding of landscapes and environments. But how does it work, you ask? How does this incredible technology reveal so much? Well, imagine shining a flashlight into a dark room. You see objects because light bounces off of them and back to your eyes, illuminating the space. LiDAR works in a similar way, but instead of a flashlight, it uses lasers, and instead of your eyes, it uses highly sensitive detectors to capture the reflections. These detectors measure the time it takes for the laser to bounce back, creating a precise, three-dimensional map of the environment. This technology is not just about seeing the world, it's about understanding it in a whole new dimension. From urban planning to environmental conservation, from archaeology to autonomous vehicles, LiDAR is paving the way for innovations across various fields. As we continue to explore and map our world with LiDAR, we unlock new possibilities and gain deeper insights into the very fabric of our planet. The universe of data that LiDAR provides is vast and ever-expanding, offering us a clearer, more detailed view of the world we live in and the worlds we have yet to discover. So, as we journey forward, let us embrace this technology and the endless opportunities it brings, illuminating the path to a brighter, more informed future. LiDAR systems emit pulses of laser light and measure how long it takes for those pulses to return after bouncing off objects. This process, known as time-of-flight measurement, is fundamental to how LiDAR operates. By timing these light echoes, LiDAR can determine the distance to those objects with incredible precision. This precision is crucial for applications ranging from autonomous vehicles to topographical mapping. Imagine a stream of photons, those tiny packets of light energy, traveling at the speed of light, bouncing off a tree, a building, or even a blade of grass, and returning to the LiDAR sensor. Each photon's journey is a testament to the speed and efficiency of light. Each returning photon carries a piece of information, a data point that contributes to creating a detailed three-dimensional map of the surrounding environment. These data points are like pixels in a digital image, but in 3 dimensions. Millions of these data points are collected every second, forming a dense point cloud that represents the shape and structure of the world around us. This point cloud can be analyzed to reveal intricate details about the environment. This technology is not just about creating pretty pictures, it's about unlocking a deeper understanding of our planet. LiDAR helps scientists and researchers gain insights that were previously impossible to obtain. With LiDAR, we can measure the height of trees in a forest, providing valuable data for ecological studies and forest management. Monitor the erosion of coastlines, which is essential for understanding the impacts of climate change and planning coastal defenses, and even track the movement of glaciers. This tracking is vital for studying the effects of global warming on polar ice and predicting future sea level rise. LiDAR's ability to capture such detailed and accurate data makes it an indispensable tool in modern science and technology. Now you might be wondering, how is LiDAR different from other remote sensing technologies like sonar and radar? Well, sonar uses sound waves to map underwater environments, often used in marine navigation and underwater exploration, while radar uses radio waves to detect objects and measure their speed, commonly used in aviation and weather forecasting. LiDAR, on the other hand, uses light waves, which are much shorter than sound or radio waves, allowing for finer detail. This allows LiDAR to achieve much higher resolution and accuracy in its measurements, making it ideal for detailed mapping. Imagine trying to measure the thickness of a hair with a ruler versus a micrometer. The difference is significant. LiDAR is the micrometer of the mapping world, capable of detecting subtle changes in elevation and capturing intricate details that would be invisible to other technologies. To truly appreciate the power of LiDAR, we need to take it to the skies. LiDAR, which stands for Light Detection and Ranging, is a remote sensing method that uses light in the form of a pulsed laser to measure variable distances to the Earth. Airborne LiDAR systems, typically mounted on aircraft or drones, are revolutionizing the way we map and understand our world. These systems are used to create large-scale maps of cities, forests, and coastlines, providing detailed and accurate data that was previously unattainable. Imagine a small plane soaring over a dense rainforest. The LiDAR system on board is capturing every detail of the terrain below. On board, a LiDAR system is hard at work, sending out thousands of pulses of laser light every second. These pulses bounce off the forest canopy, the ground, and everything in between, and the system records the time it takes for each pulse to return. These systems consist of four main components: a laser scanner, a GPS receiver, an inertial measurement unit, and a computer. The laser scanner emits the laser pulses and measures the time it takes for them to return, providing distance measurements. The GPS receiver determines the precise position of the aircraft, ensuring that the data is accurately georeferenced. The GPS receiver determines the position of the aircraft, while the inertial measurement unit measures its orientation and movement, accounting for any shifts or tilts during flight. The inertial measurement unit is crucial for maintaining the accuracy of the data, as it tracks the aircraft's movements in real time. The computer then combines all this information to create a precise three-dimensional map of the terrain. This map can reveal hidden features such as ancient ruins or underground structures that are not visible to the naked eye. With its ability to penetrate dense vegetation and provide high-resolution data, airborne LiDAR is an invaluable tool for researchers, urban planners, and environmentalists alike.